Alright, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, I bid to my fellow friends and also my dear viewers. Good morning. Alright, so today we're going to learn about a specific section in organic chemistry. So as you all know, organic chemistry is a very vast and complex part of chemistry, and it is simply because organic chemistry is contributed by the molecular complexity of a carbon compound. So why is it complex? First of all, it's because a carbon compound can form multiple bonds with different substituents and also functional groups. And then you can also put chains and arrange the bonds of the carbon differently. And so first, the compound that we've been given is hexanoic acid. Hexanoic acid is C6H12O2. And so here is the main structure of hexanoic acid. It has 6 carbons, which is represented by the black balls, and also the functional group carboxyl, which is the functional group for the homologous series of carboxylic acid, which is COOH, the O's being the blue balls. And so, to show isomerism in hexanoic acid, I'm going to talk about chain isomerism first. So the first chain that we can form from this basic hexanoic acid is this one, which is 2-methyl pentanoic acid, which means that instead of having a straight 6 carbons in the middle, we take 1 carbon from the straight chain and branch it out on the second carbon here. On the second carbon, here's the first and second, meaning to say that here there's a chain of the second carbon on the compound. And so the differences between this one and the basic hexanoic acid that I showed you earlier is, first of all, it has different physical properties due to the branching. More branching equals to a lower boiling point, and it also has a different arrangement of the carbon skeleton. It has the same chemical properties simply because it has the same functional group, which is this carboxyl group, and so all the chemical reactions will be the same for this and also for hexanoic acid.
So now I will explain to you the second chain isomerism for this compound. So we look at the longest carbon chain, which is 1, 2, 3, 4, 5. The longest carbon arrangement is 5, so pentanoic. But you see the alkyl group is attached at the 3rd carbon, so it means that it was 3-methyl pentanoic acid.
Chain isomerism is 2,2-dimethyl butanoic because as we see, they have 4 carbon longest carbon chain, which is 1, 2, 3, and 4. So at the two carbon, they attach 2 methyl, which is 1, and this. So it is dimethyl. So 1, 2, 3, 4 butanoic. So the total is 2,2-dimethyl butanoic acid.
So for the next chain isomerism, it still have the 4 carbon as the longest chain, so it will still become butanoic acid. But for this time, we put the methyl and methyl at the 2nd carbon and 3rd carbon, so it becomes 2,3-dimethyl butanoic acid. So it's still a chain isomerism.
Longest chain dia apa? 4. So dia punya so the metal attached to what carbon?
Second and third carbon.
Second and third. Bila saya tertinggal dah lektor. Satu batang tu, 100.
Oh, dia dah cabut dah, Bi. Dia dah cabut.
Ambil box.
Jangan pakai. Nampak? Nanti tak payah pakai. Nanti keluar dalam ni.
Okay. For the fourth chain isomerism is 3,3 dimethyl butanoic acid. Okay, so we see here it is the first carbon, second carbon, and the third carbon. Okay. At the third carbon there is 2 methyl attached. So the name is 3,3 dimethyl butanoic acid.
Okay, lebih baik everyone masa record jangan apa buat bunyi model. Okay.
Okay, now let's move on to functional group isomerism. So the first molecule that we would like to show in functional group isomerism is the one that I hope right now is methyl pentanoate. So why is it called functional group isomerism? Because compared to the others, the carboxylic acid structures just now, it has different functional group, which is this is COOH or cyl group, and this one is
Is the carboxylate group for esters.
yeah.
So as you can see here, for carboxylic acids, the only functional groups that they can functional group isomerism that they can form is from carboxylic acid to esters.
Okay, so as you can see at the structure that Zia is holding, it has OH bonding, which gives rise to hydrogen bonding. So it gives the properties of being able to soluble. It is soluble in water, but if you look at this structure as the structure, it has no hydrogen bonding, so it is not soluble in water. So we can conclude that in functional group isomerism, although it has same molecular formula, but it has different physical and chemical properties. Thank you.
Okay, seterusnya the functional group isomerism adalah ethyl butanoate. So dia pindah je. Tadi dia ethyl dekat carbon yang ketiga. Dia punya functional group. So dia jadi methyl butanoate. Okay.
Alright, next functional group isomerism is propyl propanoate. Now this one is also different from hexanoic acid in that the functional group is a carboxylate or ester, whereby the COO group is in between here, the third and the third carbon. So here, this one, these three will form the alcohol part of the ester. This is where propyl comes into play, and then this is the carboxylate acid part of the ester, and this is where propanoate comes into the molecule. So the difference between this one and the difference between propyl propanoate and hexanoic acid is that it has, as mentioned earlier, it has different functional group, thus it will also have different chemical properties.
Okay, the next one is functional group isomerism, which is ether. This is pentyl metanoate, which is 5 carbon for pentyl and 1 carboxylic acid, so pentyl metanoate.
Okey, saya nak tanya grup 3. Untuk bahagian carboxylic acid ada berapa isomerism? Berapa bentuk berbeza?
Carboxylic acid.
Yes, only carboxylic acid. Jangan fikir untuk ether dulu. Ada berapa?
Ester. Oh, untuk chain isomerism
Chain isomerism.
Chain, okay, dia hanya ada structural isomerism, dia hanya tunjuk tu, and chain isomerism we have about 5.
Chain.
5 is 6.
6.